We're given the exponential equation a raised to the power of b equals b raised to the power of a, and a and b are different positive integers. We're asked what is the value of a and what is the value of b. Let's first list out the set of positive integers. A positive integer would be in the set 1, 2, 3, 4, 5, 6, and so on. So we want two different numbers from this set that would satisfy the equation a raised to the power of b equals b raised to the power of a. Meaning the base on the left side of the equation must be the same as the exponent on the right side, and the exponent on the left side of the equation must be the same as the base on the right. So one way to try to solve this equation would be trial and error, where we just select two different values from this set, perform substitution, and see if it works. Let's begin by doing this. Let's let a equal 1 and b equal 2. So if this was our solution, then it must satisfy this equation, which would be 1 to the second equals 2 to the first. And this is not true because 1 squared, or 1 to the second, is 1, and 2 to the first is just 2, and of course 1 doesn't equal 2, and therefore this is not our solution. Using trial and error again, let's try a equals 2 and b equals 3. So if a equals 2 and b equals 3, we'd have the equation 2 to the third equals 3 to the second, which again is also not true. 2 to the third is equal to 8. 8 does not equal 3 squared, which equals 9. Which means a equals 2 and b equals 3 again is not our solution. So thinking about this another way, if these two exponential expressions are equal to each other, they must be able to be written with the same base, which means we need to select a value of a and b that could be written with the same base. And because 4 can be written as 2 squared, let's let a equal 2 and b equals 4 and see how this works. We can write these with a common base of 2 if needed, because 4 is equal to 2 squared. Performing substitution, a to the power of b would be 2 to the fourth equals b to the power of a would be 4 to the second. I think this will actually work. 2 to the fourth means we have 4 factors of 2, which is 16. 4 squared means we have 2 factors of 4, which is also 16. So this actually does satisfy our exponential equation, and therefore the value of a is 2 and the value of b is 4. We could also show these are equal by obtaining a common base. For example, if we start again with 2 to the fourth equals 4 to the second, again we could write 4 as 2 squared, so we could write this as 2 to the fourth equals 2 squared to the second. Again, here's the 4. When we have powers to powers, we multiply the exponents. So here we have 2 to the fourth does equal 2 raised to the power of 2 times 2, which is 4. Here's another way to show that a equals 2 and b equals 4 is a solution. Let's look at another example. Here we're given a to the power of c equals b to the power of c, and a and b are different non-zero integers. So if we look at the equation a raised to the power of c equals b raised to the power of c, notice how here the two exponents are equal to each other, but the bases, we're told, are non-zero integers. So how can we have different bases and the same exponent and these two expressions be equal to each other? That's only going to happen with one value of c, and that's when c is equal to 0. One of the exponent rules is a raised to the power of 0 is equal to 1 as long as a doesn't equal 0. So if we select two different non-zero integers, let's say we let a equal 5 and b equal 2, performing substitution with c equal to 0, we would have 5 to the 0 equals 2 to the 0, and again both of these are equal to 1, so we'd have 1 equals 1. It's also true if we have a negative integer. For example, if we try, let's say a equal negative 3 and b equal 9, and again c is 0, we would have a, which is negative 3 in parentheses raised to the 0, and we do need parentheses so that the exponent of 0 is attached to the base of negative 3, equals 9 to the 0, and again, both of these are equal to 1. So our answer here is C is 0. Okay, I hope you found this helpful.